So as I was saying, right, if you go back to the sum over here, right, I'm going to zoom this thing out. So in order to find the mole fraction of sodium hydroxide, you need the mole amount, but the mole amount is not given, but they gave you the gram. So from the gram, you can get the mole amount if you know the molar mass. Do you know the molar mass? Yes, you can calculate it. Sodium is 23, oxygen is 16, hydrogen is 1. So all you have to do is add them up, right? And that number you divide the grams given by this number, you will get the number of moles of sodium hydroxide. And then coming into water, H2O, you're supposed to get the mole amount again to find the mole fraction. But they haven't given it to you. They gave you the gram. Don't worry, you have the molar mass. If you divide the gram by the molar mass, you will get the mole amount. Okay? Now that we have found the mole amount, all you have to do is, if you are considering sodium hydroxide, write sodium hydroxide mole up and the total down. What is the total, Puta? Right, tell me the total.
40.
Hmm, why 14, Puta? Here, see, can you see the red line and the green line? Right? So the number of moles of sodium hydroxide is 1. The number of moles of water is 10. So what's the total? It is 11. Does that make sense?
Oh, okay. Yeah, yeah.
We are adding moles now because we are finding the mole fractions, Puta, not mass fractions. Okay, right. So the mole fraction
Yeah.
of sodium hydroxide is 1 over 11. Now, if I tell you to find the mole fraction of water, what would you do? Raida?
10 over 11.
Ah, makes sense. Easy?
Yes.
Okay, so this is the theory of finding mole fractions. So you can see over here, right? 1 over 11. 1 over 11 is the sodium hydroxide's mole fraction, and the mole fraction of water is 10 over 11. So if you add these two, can you see you're getting 1? 10 over 11 plus 1 over 11 is 11 over 11, that is 1, right? The sum of the mole fractions in a component is always 1, right? So that's basically uh, what we know. And then Puta, here there's something called parts per million. So what is that? That term you should just know. Even if you see baby medicine, they will syrups, basically they will mention as V over V and ppm. Just if you have any uh, baby syrups, right? Or even you will have it in creams and all. Just check it, okay? Check some cream bottles and so on. You will find the composition of the components mentioned in volume fractions or mass fractions, right? And also ppms. So you, what is this ppm thingy? We'll see that. So the sum of a mass fraction or volume fraction of all components in a mixture is equal to 1. There are no units for the mass fractions, volume fractions, or mole fractions of a mixture. The composition of a mixture expressed as a fraction can be expressed as the percentage or parts per million. So what is that? Composition of the percentage, fraction into 100. Composition as parts per million, that is fraction into uh, 1 million. So why are we multiplying things by 1 million? Because Puta, when we are working with these chemicals, we are working with very minute amounts, right? So it's easier if we can give this. like minute amounts in the sense that we are working with mole fractions kyanne. Now you should understand 1 mole is 6.022 into 10 to the power 23 atoms, right? So that tiny are these compositions that we are working with, and we have a whole bottle of 1 liter or 1 liter cream or whatever it is. So it's not easy to see that amount in a bottle, right? So what we do, we multiply it by million to understand how much of that composition is in these things that we use, right? So that's why we have this parts per million. Okay. Now we have something called um expressing composition of a mixture in terms of mass per volume, right? Mass per volume. How much of mass is in a particular volume, right? So that is again, Puta, it's easy. All you have to do is divide the mass given by the volume of that particular solution. If you're going to dissolve, look at this G1 is solution, 5 grams of sodium chloride. Find the composition of the sodium chloride in terms of mass over V. So if you are going to dissolve this 5 grams of G1 in 1 cubic decimeter, how much of what is the composition of the solute? That's 5 grams per 1 cubic decimeter. So this is exactly how you write it. So over here you can see put the 5 grams per cubic decimeter. Per cubic decimeter. This 1 decimeter unit comes up as a minus 3. Make sense?
Yeah, miss.
Right. Now we are coming into something very important, that is moles per volume. Why do I say that this is important? Because moles per volume is, in other words, what? Number of moles per volume. Okay, give me a minute. Okay, give me a minute. All okay. So, what do we mean by moles per volume, Puta? What is it? Why did I tell that is very important? Because,
How many moles are there in per volume? Like,
yeah. So, why is it important in chemistry? Because
mm,
we often use this in chemistry. That is why it's important in chemistry. Okay, so whenever we take a solution, Puta, we always look for the concentration. How much is it concentrated, right? So moles per volume, in other words, is concentration. Okay. So what does this mean? This means how many moles of something is dissolved in a particular volume, right? Now look at this equation. Look at this worked example. 2 cubic decimeter of a solution contains 4 moles of sodium hydroxide. Find the concentration of this solution. So what do you have to do? All you have to do is put this equation. C equals N divided by V. You have the uh, C equals to N divided by V. So number of moles is given, volume is also given. So all you have to do is multiply, divide and get the answer, right? Okay. So now over here, why have they written this over here? 2 divided by 4 divided by 2 into 1. That is to say how many number of moles is the number of moles of sodium hydroxide in 1 cubic decimeter. If I want how many is in 1000 cubic decimeter, then I have to multiply it by 1000, right? And if they ask you how much is there in 500 cubic centimeter, then this value I have to multiply it by 500. Does that make sense, Puta? So once you find the concentration, most of the things in chemistry are going to get cleared, right? Okay, sometimes you see, Puta, they won't give you the number of moles, right? To find the concentration, what do you need basically, Puta? If I go to my paint screen and scroll all the way down, in chemistry, if you want to find the concentration, you need N divided by V, no? Right? You need the number of moles and the volume, okay? That you're going to dissolve it in. But what if they don't give you the number of moles? They can give you the mass, right? From the mass, you can find the number of moles. How? You divide the mass by the molar mass. So, the concentration can also be found by M divided by M and that value divided by V. Agreed? Does this make sense?
Yeah, miss.
All right. Okay. So let's see this example. Okay. As I was telling, the next example is that. Look at this, Puta. What is the mass of glucose? Now, it's a little bit of a twist here. What is the mass of glucose required to prepare 1 cubic decimeter of a 1 m glucose solution? So with this, instead of reading this whole thing, moles per cubic decimeter, you can tell it as M, capital M. We use capital M in chemistry instead of using this entire thing. Even like you see in Newton, what is Newton, Puta? That is F equals ma, right? So ma, mass is kg, right? A is ms minus 2. So instead of writing this every time, we use Newton. So same, something like that. Okay, when we are doing sums, we will just write it as 1m solution. Okay, does that make sense? Right?
Yeah, miss.
Right, okay.
Yeah.
So look at this one, Puta. What is the mass of glucose required to prepare 1 cubic decimeter of 1 m glucose solution? For this, 1 mole of glucose solution is required, right? Uh, the so why do you need 1 mole of glucose? Why? Because that is what they want you to prepare, right? They want you to prepare 1 mole of 1 mole in uh 1 cubic decimeter. Per cubic decimeter there should be 1 mole, so you need 1 mole. So you can't measure moles in a lab, right? So what can you measure on a bench? You can measure the mass. So you have to find out how much of glucose will weigh one or how much of glucose will it be for 1 mole, right? What is the weight of it? What is the mass of it, basically? So, molar mass of glucose, first of all, you have to find the molar mass, right? And then what do? You here basically, Puta, what they have done is they have calculated m over m is equals to n. If you need 1 mole, that is 1 mole, you don't know how much to take of mass, but you know the molar mass. The molar mass again you can calculate it, no? That is what they have calculated at the beginning of the sum itself, right? 180, right? So 1 mole into 180 g mole minus 1, right? Would be 180 grams. So you need 180 grams if you want 1 mole of glucose, right? So this is how you prepare 1 mole cubic decimeter per cubic decimeter solution of glucose. So what are you supposed to do, Puta? You're supposed to take, what it means is you are supposed to take 1 cubic. இதுதான் இதோட meaning. Okay, the simple meaning is you are supposed to take 1 cubic decimeter of water and add how many grams? 180 grams of glucose, C6H12O6. And then ultimately, if you nicely give it a stir, what have you prepared here? You have prepared 1 mole per cubic decimeter இருக்கிற ஒரு glucose solution நீங்க செஞ்சு இருக்கிறீங்க. Does this make sense?
Yeah, miss.
Yeah, right? So how do you get this 1 mole cubic decimeter, the 1 mole? You can't measure 1 mole, Puta, in the lab. It's impossible. How can you count 6.022 into 10 to the power minus, sorry, 10 to the power 23 atoms? Can you do that? Can you count this many molecules in the lab? You can't.
Yeah.
That's why we measure it. 180 grams of glucose is, in other words, 1 mole. Or, in other words, 6.022 into 10 to the power 23 molecules. Okay? So, this is what we call it as concentration. Moles per cubic decimeter. Right. Okay. So, then, Puta, they're asking you another question. Right? So inshallah we'll be working on another sum also, right? Okay. So let me just erase this. Right. The second sum, right? The second part of the sum is work out the mass of glucose that should be weighed to prepare 500 cubic centimeter of this particular glucose solution. Right? The mass of glucose required to prepare. Now, මෙහෙමනි පුතා මේ ගාන බලන්න එපා. ඕගොල්ලොම මට කියන්නකෝ. Like, don't look at the answer, right? Just think and tell me, Puta. You have to prepare 1 cubic decimeter, you need 180 grams, no? Right? 500 cubic centimeter කියන්නේ 1 cubic decimeter da half. Melangita, did you all understand that? 1 cubic decimeter, in other words, is equals to 1000 cubic centimeter. Now, if I want only half of it, how much of grams should I add to this particular container? How much of glucose should I add, Raida?
250.
250. No, Puta. Now, the
No,
volume of
half.
the water is water half edited, right? The solution, the water I have taken not 1 cubic decimeter, one not 1000, I have taken 500 only. So how much of glucose should I add to this half if I want only half of the composition?
Half.
So how much is it? How much of glucose should I add out of this?
1/2.
1 over 2? Half a mole, you mean?
Yes.
Okay, how much is half a mole in grams in here? It's going to be 180 divided by 2. That is, how much is it?
90.
90 grams, right? Give me a minute. Go through this calculation part, Puta. All right, I'm back. Okay, so as I was telling Puta, over here, if you want the same, now I divided the 1 cubic decimeter, right, to have 500 cubic centimeter, and I divided the 180 grams also by 2 to get half of it. Now, what is the concentration of this particular solution, Puta? Now, I'll rewrite it. 100 and if I dissolve 180 grams in 1000 cubic centimeter, I get 1 mole per cubic decimeter, right? And now I'm going to dissolve 90 grams in 500 cubic centimeter. What is the concentration of this particular solution, Raida? What do you think, Raida? Hello. Any idea? Okay. Is my voice lagging? Moaz, can you hear me?
Yes, teacher, I can hear you.
Right. Okay. So, yes. I'll ask the question again, Buddha. Listen to me very carefully, okay? You have 180 grams, right? Dissolved in 1000 cubic centimeter, right? And you get 1 mole per cubic decimeter concentration உள்ள ஒரு glucose solution உங்களுக்கு கிடைக்குது. Okay, right. Now what I do, I get 90 grams of uh, s- uh, 90 grams of glucose dissolved in 500 cubic centimeter of water to get what kind of a solution? What is the concentration of this would be? Yes, that would be 1 mole per cubic decimeter again. Right? இப்படிதானே புத்தா இப்ப உங்களுக்கு திக்கான டீ ஒன்று வேணும் right? Okay, let's tell it like that. Okay, you're going to put 2 spoons and no milk, let's tell it like that. Okay, you need because tea there's too many components in the mixture, so you need 2 spoons of milk, right? And then you are adding 1 cup of uh, water, and then you are blending it to get the milk. I don't know, whatever it is, right? So it's 2 spoons and 1 cup of water, you get a perfect smoothie. I don't know, right? So now this time you're going to make it for 2 people, right? But you need the same texture, the same taste, so you're going to increase this by 2, right? So that would be 4 and 2 cups. Still, you get the same taste. Why? Because nothing changed, only the quantity changed, right? Only the quantity changed, but the taste remains the same. So, similarly, you can see idum half avi chanda, then the concentration is actually the same. But now you see what I'm going to do. Pay attention, okay? I'm going to cut this thing. Copy, cut. And new. I'm going to do this way. I am going to use 180 grams, right? I'm going to take 180 grams, but I'm going to dissolve it in only 500 cubic centimeter. Now, what do you think will happen to the concentration? What do you think will happen to the concentration, Puta? I used,
Uh, it
yeah,
would be, it won't be the same, like,
yeah, it
uh,
won't be the same. Now, the question is, will the sweetness increase, the concentration increase, or the concentration decrease?
it would increase
Very good. It would increase. How much will it increase?
twice.
Twice. Yes, it is. So the answer is 2 moles per cubic decimeter, right? Okay, so inshallah, when we are doing sums, Puta, this is just the very first time you're learning about this, right? So no need to worry about it, right? When we are doing multiple sums in this regards, inshallah, you will definitely get the hang of it, right? Okay, so let's do some sums before we come into the more complications. இப்பக்கி சொல்லி கொடுத்ததெல்லாம் தலையில ஒழுங்கா இக்கிதாண்டு பார்க்கறதுக்கு we'll do some sums, okay? Right, let's do this chart over here. Okay, right. Raida, start doing this chart, Puta. I'll just copy paste it over here. Right. Tell me the answers. Just work them out. Can you? Okay, let me explain the first one. So you have sodium hydroxide, 40, they have given you the molar mass also, so it's easier for you, right? So the equations that you have to keep in mind is to find the number of moles. What is the equation? N equals simple M over capital M. Mass over molar mass. And concentration is equals to N divided by V. Number of moles divided by the volume. So, to find the number of moles, the final one is concentration. So, they need you to find this, right? So, in order to find this, you need the number of moles over volume. The volume is given, but the number of moles you need to find. So, that is given over here. So, that is why you are going to divide the mass by the molar mass to get the number of moles. And then you divide that by the volume given, and then you will get the answer. But now, Puta, there's a small problem. நான் சொல்லிக்கொண்டே இருக்கிறேன் என்னது concentration is equals to n divided by v, n divided by v என்று இங்க நீங்க என்ன ஒரு எக்ஸ்ட்ரா ஸ்டெப் கொண்டிருக்குது இது என்னது இது now if I want to divide the concentration to get the concentration number of moles, here see number of moles is already found out, okay, 0.25 divided by how, what is the volume, okay, 200. This should be the sum, no? What is this 1000? Raida. What is this 1000, Puta? Any idea?
Uh, the amount, like, uh, how many of NOH? Like,
So that is concentration. No, concentration is you have the number of moles divided by the volume. So what is this 1000? You know, you know what this 1000 is? This 1000 is actually, Puta. Can you see the volume is given in cubic centimeter?
yeah.
Ah, but they want you to find it in cubic decimeter.
Um,
Ah, how
the
much do you
value is,
think 200 cubic centimeter, you have to convert it to decimeter and only put it here. Here. You can't just put 200. Understood? So instead of
Yeah.
writing this, right? I'm going to erase this, huh?
Miss, then if it was the other way around, you have to divide it by 1,000, right? The whole thing.
Yes. Here also we are dividing it, Puta. But why is it coming up? They have, yeah, they have missed a step. Like, uh, uh,
A
thinking,
1,000 over 1, right? It
1001.
by
Okay, let me,
200
let me, let me explain this, Puta, Raida, and then see if you can understand. This is actually C. What is C equals to, Raida? C equals N divided by V, no? So
Yeah.
0.25 divided by 200 divided by 1000. Why? Because I'm converting it into cubic decimeter. Ah, you are telling if they give you the cubic decimeter and tell it to convert it to
Yeah.
cubic centimeter. Ah, yes, yes, yes. Yes, you are supposed to multiply by 1000. But Puta, mostly this is the way that they give you. Because 1 cubic decimeter is the international standard unit for concentration. Mole per cubic decimeter is the international standard. That is what you call it as capital M, 1M. Okay. So if you are going to solve it, Puta, how do you write it? 0.25 divided by 200 over 1000. So this is actually 0.25 into 1000 divided by 200. Isn't it the same thing?
Yeah, it is.
Ah, the problem is they are missing steps and writing, right? So
Yeah.
thinking that the students will understand, right? So that is where teachers comes into play. No, like we have to explain these steps. That is why පුතා අපි මෙහෙම කරන්නේ කියලා. හරිද? All right. Okay. Now go ahead and finish off the rest of the three, Puta. Now work it on the textbook itself and let me know the answers. Have you finished them, Puta?
Yeah, miss.
Okay. What is the answer for the first one? I mean the calcium chloride, second one.
0.5.
Okay, good. Sodium carbonate.
0.25.
Okay. HCl, hydrochloric acid.
2.
Okay, good. Right? So those are the answers. You got the hang of it, right?
Yeah.
Okay, Alhamdulillah. All right. Okay, now back to the theory. We are not done with the calculations, okay? There are some more stuffs to learn. Okay. Right. So we are done till here. Preparation of standard solutions. So that's what I was telling you all the time, that there are some standards in chemistry, right? So we are always working with 1 liters basically most of the time, right? 1 liter. We don't tell 1 liter though. We keep on